Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Friends, today we are starting another concepts in three hinge arches is nothing but circular arch. Okay, now in circular arch there is a little bit difference in formula of y. What is that difference? Let's see in details. Now see friends, this is a circular arch concepts and their problems. So now in circular arch we have given this arch. See in exam you have to draw only this type, this line, this over here in the exam. This part only you have to draw. You don't need to draw this whole circle. Okay. Now this is a circle, circle, and this is a circular arch. This is one hinge, this is second hinge, this is your third hinge. And see in this, if you are taking section over here, this distance is y, but x distance is this over here. This is your x distance. In previous case what we are taken, this is x and this one is y. But in circular arch, what circular says, always take the origin at center, means this is nothing but your origin over here. Okay, always take the origin, not center, or always take the origin at center, means here you have to take the origin of the circular arch, means this is your x distance and this is your y distance. Or in that formula for circular arch, that is little bit changes in formula of y is equal to under root r square minus x square minus r plus h, or r is equal to L square upon 8h plus h by 2. In this concept, please remember, you cannot use the formula of y is equal to 4h upon L square minus x square. You can use this formula for using y under root r square minus x square minus r plus h, or r is equal to L square upon 8h plus h by 2. Remember these three formulas and we have solved the problem on the circular arch, and you can better understand. For better understands you this concept, let's move into problem number 5. In circular arches problem number 1, but in three hinge arches problem number 5. Now see, this is a question given to your exam is a circular arch rib is 20 meter, means rib will be 20 meter and span with central rise of 4 meter, span will be 4 meter, is hinged at the crown, means hinged at the C point, and springings full stop, it carries a point load of 100 kilonewton at 5 meter from the left hand hinge. Calculate reaction, horizontal thrust, maximum positive and negative bending moment. Now let's, here not given the diagram, so draw the diagram first. Start with this solution. Now this is the diagram. Now see, this is a diagram. Now see, span rib will be 20 meter, means nothing but your span, arch rib of 20 meter span, the span will be 20 meter over here, and after that, and central rise of 4 meter, means h is equal to 4 meter, central rise is 4 meter. Now at the crown, and it carries a point load of 100 kilonewton at 5 meter from the left hand hinge, means from left hand hinge we have to apply the 5 meter from the left hand hinge, means over here. This is 5 meter and this is a point load of 100 kilonewton, and this is a question given to you. Now after that, now we have to find the reaction first. For reaction, as you all know, this will come like this. This is VA okay. Now our first step we have to find over here is reaction. So let's start with this. Now first one you have to find the reaction. Reaction is nothing but support reaction calculation. To support reaction calculation, what we are seeing first, we are taking moment at A equal to 0 clockwise positive. Now let's see over here what's will come. See, this 100 is going in this direction, so it will go clockwise. So 100 into 5. 100 into 5. After that, no load is there. Directly come VB into 20 minus VB into 20 equal to 0. While solving this, you get the value of VB will be 25 kilonewton. 25 kilonewton upward. Okay, now what's our next step will be summation F y equal to 0 upward positive. Okay, now get the value of VB right over here, or you can directly find out the VSC. This VB is going 25 up and down, from upward is coming 100, so 100 minus 25 is 75. VA value will come 75. Let's see, this VA minus 100 plus 70 plus 25 is equal to 0. Therefore VA is equal to 75 kilonewton upward. Now you can check whether your reaction is right or wrong. How will you check? 100 is going from up to down, so down to up will go 100 kilonewton. So 75 plus 25 is nothing but 100. 100 and 100 will get balanced over here. Now to find the H. Now as you all know, to find the H, what we are taking, since C is an internal hinge, consider part C and B. See, when you are finding the bending moment, at C, either you can take this part or you can take this part, whichever is convenient for you, you can take that part only. Okay, now when we are taking this part, there is no, it's very simple over here, so we are taking CB part first. Now bending moment C is equal to 0, and the sign convention, as you all know, sagging positive, hogging negative. Okay, now what will come over here? See, we are taking bending moment over here, and see this side, this is going sagging, so 25 into 10, 25 into 10 minus this H into this distance 4 minus H into 4 equal to 0. Now while solving this, you get the value of H will be 62.5 kilonewton. Okay, as you all knows, HA is equal to HB is equal to 62.5 kilonewton. Both are same because it is a parabolic arch. Okay, sorry, it's a circular arch. As you all know, at same level, H is always same in 3-inch parabolic arch, because if H will not same, your arch will be moved here and there. Now see friends, now we have done with this first part reaction, and horizontal thrust also we have done. Now we have to find the maximum positive and negative bending moment. As you all knows, in previous sum we have solved how will finding the maximum positive and negative bending moment. Take section one time left and take section at right, and draw the FBD of left part, draw the FBD of right part, and take one sections, and we got the value of maximum positive and negative bending moment. Now let's see, friends, we have done with this just two parts. Now the maximum positive and negative bending moment, as you all know, how will you find this? Take section first CA part and then CD part, and take section over there and find the over there. Now let's see how it's coming that. Now our next part will be maximum positive and negative bending moment. Now third part will be maximum positive and negative bending moment. Okay, as you all know, first we have to consider first part. So consider one part. First we are considering CA. Okay, now just draw the FBD of the CA part. Just draw the FBD of the CA part over here. Now we have given the pointer also. Name it as here D. Now please students, friends, one thing remember over here, when we are taking this part A and C, always take the section at the point load, because when your point load is given, we don't know why we are taking the section, but when we have no load is given, then we randomly we can take section. But if point load is given, so take the section in the point load over only. Okay, so here we are taking the section over here only. Okay, here only, and here this distance is nothing but y, and this distance is nothing but x over here, as it is your circular arch. In previous when we are solving at same level, that we are seeing x will be this, but in circular arch x will be this. Okay, now let's start. Now this is D, so bending moment at D equal to, now we are taking section over here. While seeing this, you have to see in this side only, but you have to take x distances x, this. So this x, as you all know, this is x will be 5 meters, so this will also 5 meters, so this is also 5 meters. So when we are taking section over here and seeing this side, this will come 75 into 5, 75 into 5, then minus 62.5 into y. But here write it as equation number 1 over here. Take one note over here also, take one note. In circular arch, we have to use y formula will be r square minus x square r plus h minus r plus h, or r will be L square upon 8h plus h by 2. Here we can use this note over here. Always remember, in circular arch, use the formula of y is this. Okay, so use this formula. Y is equal to under root r square minus x square minus r plus h, considering C as, this is considering C as origin, because it is a circular. So always circular circle says take the center part as a origin. Okay, now put the value over here. Now put the value. Now put the value. So this is put the value over here, and r will be L square upon 8h plus h by 2. Now put the value of r first. Now see, L will be nothing but, your total L is nothing but 20 square upon 8 into h will be 4 plus 4 by 2 is equal to 14.5 meter. Your r will be 14.5 meter. So put in y is equal to under root 14.5 square minus 5 square, as x is your 5 over here, minus 14.5 minus 4. Okay, So it will come 3.11 meter. Why will be 3.11 meter? Means at x is equal to 5 meter from C. Please listen this, from C, y is equal to 3.11 meter. Now put in equation number 1. Now this value, y value, put in equation number 1. So we got over here bending moment at D is equal to 75 into 5 minus 62.5 into 3.11. We got over here 180.63 kilonewton meter. So this is nothing but your positive, means maximum positive bending moment is equal to 180.63 kilonewton meter. This is your maximum positive bending moment. We have find this one. Okay, now after that consider other part to find the, now one part is positive, so the other part will be negative. Now next part will be consider portion C and B. Now as you all know the sign convention, okay, now bending, now draw the FBD of the part C and B. Now this is B and this is C. Okay, this value you know 25 kilonewton, and this value also you know 62.5 kilonewton. Okay, now see, now you have to take the randomly take the section over here. So you are taking section over here like this. Your this distance is nothing but x and this distance is nothing but your y. So if this distance is x, so how much this distance is there? How much this distance is? This distance is nothing but 10 minus x. Okay, this distance is nothing but 10 minus x. Now name it over here this as E. So right over here bending moment at E is equal to 25 into 10 minus x minus 62.5 into y. But you know the value of y over here also. Okay, now see friends, bending moment at E we have written over here. Now as you all know, y is equal to under root of 14.5. See, we have find this r value over previous sum, minus x square minus 14.5 minus 4. So it will come, see 14.5 the whole square will come 210.25 minus x square and minus 10.5. Okay, so now put this in equation number this, put in this equation. So we get bending moment at E is equal to, put in this equation, okay, now into over it. Now 250 minus 25x minus now into in the bracket, so it will come 62.5 under root 210.25 minus x square. After that my plus 656.25. okay, this is nothing but equation number 1. Now as you all knows, mx to be maximum d by dx of mx equal to 0. So how will you get? This will directly get 0 over here, minus 25, then minus 62.5, 2 under root of 210.25 minus x square, and this x square into minus 2x, this 2 and this 2 will get cancelled, plus 0 is equal to 0. Okay, by solving you get the value of x will be 5.38 meter. 5 point, put in equation 1, means you have to put in this equation over here. Okay, put in this equation, this is in like this. Okay, put in this equation and you get the value of bending moment at E over here. (250) minus 25 into 5.38 minus 62.5 under root 210.25 minus x square. सर ये पेज कट करो, समझ में नहीं आ रहा साला, रखता हूँ भिंडी. Bending moment at E equal to 250 minus 25 into 5.38 minus 62.5 under root 210.25 minus 5.38 the whole square plus 656.25. Okay, now we got the bending moment at E will be minus 69.811 kilonewton meter. Okay, means this is nothing but maximum negative bending moment is equal to 69.811 kilonewton meter. Okay, now we have done with this part. Now after that, if we solve maximum positive and negative moment, you can draw the diagram also. So draw the bending moment diagram. Draw the bending moment diagram. Okay, so how will you draw the diagram over here? See, as I am explaining you, see, you are solving a circular arch. That's why first draw the one arch like this. Okay, after that, see, this is your A, this is B, and this one is C. Now see, we have the value, got the value over something over here at this load. So and here there is no load, that's why it directly get over here. Now this is your positive bending moment, this is your negative bending moment. This is nothing but 69.811 kilonewton meter. This will be 180.63 kilonewton meter. Okay, this will 180.63 kilonewton meter over here, and this distance is 5 meter, and over here this distance will be 5.38 meter. Okay, and the whole span will be 20 meter. Okay, now here we have done this problem. Now I am just showing you one by one. Now see, this is a question given to you. Just recall this. This is a question given to you, and this is the diagram of this question. This is the diagram of the questions. After that, first you find reaction VA and VB. After that, C is an internal hinge. You can find H. After that, maximum positive and negative bending moment. For positive bending moment, first take the, you don't know the what is which part is positive, which is negative. So you randomly you can take section, directly come positive means positive, negative minus sign will come means negative. So you can take first part, draw the FBD of that part, and take section in the point load, and use this formula and find the R over here, and Y find, and X is equal to 5 meter, C Y is equal to 3.11 meter. Now we got the over here positive value means maximum positive bending moment. After that, consider the other part same as it is. Take one section, and this is your X and this is Y, so this distance will be 10 minus X. When we're taking bending moment from this side, we want this distance, don't want this distance. We don't know this distance. In the previous one we know the distance over, so 10 minus X will be the distance. So remember these things also. This is very special case. Okay, after that, this is your maximum negative bending moment, or you can find the, draw the bending moment diagram also. This is your final answer. I hope you understand all the concepts, and please share with your friends, and don't forget to subscribe the Ekeeda channel. Thank you.